In this video, we will talk about types of simple machines. So, when you talk about machines, what they simply do is they basically makes our work easier and efficient. So, whatever we gave the input, they basically convert it into the output and makes it easier for us. Input means whatever the force that you are putting it, and output means whatever the work that the machine is doing in order to make your work easier like that. So this is how easily you can understand the role of simple machines. And accordingly, we have divided them into the different types. So there are six main types of simple machines which you can see here. One by one, we will look at them and understand what are they. So first of all, the first type is lever. The second type is inclined plane. The third type is wedge. The fourth is pulley. The fifth is screw. And the sixth is wheel and axle. So when you talk about lever, so lever is something where you can simply understand how the position of a fulcrum, the position of a object, or what you can say here is load actually, and the position of the force, which is actually the effort, can change the overall work that you are doing. And accordingly, the position of these three things divided the lever into three types, which is first class lever, second class lever, and third class lever. And the utilization of lever is something you can see within your body as well, like the working of our skeleton, the bones and the joints works on this principle of lever. There are a lot of machines that we use in our day-to-day life as well, like the nutcracker, the wheelbarrow. There are a lot of things that we use are basically works on the same principle as well. Okay, so this is how we have divided the lever into three categories. Then you have the inclined plane, which is nothing but a surface, a frictionless surface, which can actually utilized in order to keep a heavier object to some higher place. Means, let's say you want to lift up some object and it is very heavy and you can't just lift up easily. So you just simply push it on this inclined plane, this slanted surface, what you can say. A very simple idea of this is basically, let's say you want you bought a car and now your house is a little bit up from the road. So how you will take the car inside the house? So you need that inclined plane so that your car can go inside the house. So this is how easily you can understand the role of an inclined plane as well. Even if you go to the mountains, the roads are not simply like you can simply go to the top mountain like the straight road. It always goes round and round and round. So it basically gives you the inclined plane so that you can climb the mountain easily. So this is how you understand the role of inclined plane. Then you have wedge. Wedge is nothing but when you are applying the force onto a very particular object at a very particular place. So this is a force. This is a point where you are applying the force. So simply taking an example of a nail. When you are hitting the nail with the hammer, it will stuck to a point. That is how you can understand the role of wedge. If you have a very blunt object, it is very difficult to just insert it into the something, which can be done easily by the wedge. Then you have pulley. Pulley is doing something very similar to the inclined plane, but the inclined plane can only go up to a certain height. But if you go to a very bigger height, or if you want to move object from one place to another which is very heavy, in all of those instances you can actually use the pulley. So there are two types of pulley, which is fixed pulley and movable pulley. Means this is your pulley. So in one instance, I mean in fixed pulley, the pulley is not moving. Only the object and the force is like something which you can actually move here and there. Apart from that, there is a movable pulley where is like your pulley can actually move. Okay, and which again makes your work easier because sometimes you need a movable pulley like that. So that is a pulley for you. Then you have a screw, which is again very similar to the wedge, but then it has these turns. So these turns basically increase the surface area, because sometimes you just can't insert the nail every place. Sometimes you need a screw like a thing, so that it just have a greater what you can say binding capacity. It's just not simply like you have used it and then simply you taken it out. Sometimes using a nail can break the object as well, but utilizing a screw makes it much more better and easier as well. That is how we can understand the role of screw. And lastly, we have a wheel and an axle, a simple object where you have this wheel you can see, and then there is an axle. So this wheel and axle are attached with each other, and it basically helps to move an object to a larger extent, like simply taking example of a bicycle. And there are a lot of other examples as well. You can basically use see the usage of wheel and axle. So this is like the different types of simple machines. Now let us discuss the very first type, which is lever. So in order to understand the lever, I told you there is a very important thing you need to understand is the position of a load, the position of a effort, and the position of a fulcrum. If you know all of these three positions, you can easily understand the lever. So a lever is a rod which moves freely about a fixed point called fulcrum or pivot point, which is this. So this whole thing that you are looking, this whole rod is a lever. So on this lever, one side you have a effort, the force that you are putting it, and the other side is the object that you are putting it. So basically it helps you to move that object. And there is a fulcrum point. Okay, so with the fulcrum point, you can actually see how that lever is moving here and there. So the weight to be moved is called the load, as I said, or resistance also. And the force applied on the lever is called the effort. And the distance of the fulcrum from the point at which effort is applied is called the effort arm of the lever, and the distance of the fulcrum from the point at which the load acts is called a load arm, which is something you can see here and here. Effort is distance between effort and fulcrum, and load arm is distance between load and fulcrum. And easily you can say this is a load arm, this is a effort. So lever is like as I said, a simple example is to remember the seesaw. Seesaw works on the same principle of lever. You have the fulcrum at the center, you have the load on one another on one end, and the another end you have the effort. And simply whoever is pushing the effort, or like whoever is pushing it, like simply putting the force, you can see the effort, and on the other side you can see the load moving up and down. Okay, and with this activity also you can see the same thing, where to understand about the effort, fulcrum, and the load of a lever, we need the materials like a big piece of a stone and a metal rod or a bamboo rod, which you can see here, this thing, and this thing. A stone, a big piece of stone, and a metal rod or a bamboo rod. What you need to do is simply is you wanted to move a big piece of stone, so you will be unable to move it. Obviously it is very big, so you will place a metal rod or a bamboo rod below the stone and apply effort near the other end. Are you able to move the stone piece now? Probably you will be able to move the stone piece easily, because the rod acts like a lever while the load, which is the stone piece, is at one end and the effort is on the other. Like this is your fulcrum first of all. Okay, as you can see it is written here. This is your fulcrum, and here you have this lever, this whole thing, and here you are putting your force, which is the effort, and this is a load. So if you get a proper crevices in order to move that, or like proper fixing that lever, you can actually move the stone to a little bit of extent. And with this simple activity, it might not need to be the stone. You can actually do this activity with any kind of heavier object, but you have to see how you're putting it, your lever in that, and what is your fulcrum that too. Because let's say if you're using a very lighter lever, it will break. So you should not supposed to use things like that as well. But with this activity, you can understand how the lever works, how the positioning of load, effort, and fulcrum can actually give you the work. I hope this will be helpful to you. Thank you.